Okay, let's graph sine, cosine, tangent with a table of values. So y equals sine x or theta. Let's use x. Excuse me, the notes is x. I'm usually doing sine theta. We know x is theta, therefore we sine angles. And let's draw a little graph off to the right. I taught you before that we just draw a 2 by a 4 only. And we mark 0 degrees and 360 degrees. And therefore halfway is 180. Okay, so I said we're going to make a table of values, so let's do that. So we got x and y. We're going to choose angles for x like 0, 90, 180, and 270, and 360. And then we're going to use our definition of sine theta. I'm going to write that way off to the right. Sine theta is equal to the y value of the unit circle. So I'm going to draw a unit circle down below. And I'm going to put just the points on. 1, 0. Remember, we have a radius of 1. The unit circle has a radius of 1, so all the points are going to have a 1. Then we have 0, 1 at the top. Then at 180 degrees, straight off to the left, we have negative 1, 0. And then straight down, we have 0, negative 1. So the unit circle. And again, sine theta is the y value of the unit circle. Excuse me, that got in the way. Sine theta is the y value of the unit circle. We're going to use it to graph this equation we've been working on. So if sine theta is the y value of the unit circle, it gets pretty confusing when x is theta. And x in the table is theta. So these angles are all theta. So the y values are just going to be the y values of the unit circle. That makes a little bit more sense. So at 0 degrees, the y value in the unit circle is 0, like we talked about in the last section. So we can put 0 in the table beside 0 for y. Now 90, when we're straight up, the point is 0, 1. And we know that it's the y value. So the y value at 90 degrees is 1. And at 180, the y value is 0. And at 270, the y value is negative 1. And at 360, the y value is 0 again. So we can plot those points in the graph that we've drawn off to the right. And we're going to do it in exactly this order, as you can see in the notes. Big blue, start, end. First point, last point, 0, 0, and 360, 0. Point in the middle of the table, 180, 0. Halfway between at the top at 91. I'm going to put a tick on my y-axis and call it 1 and negative 1. And then again in between the 2 points on the right at the bottom. Then I'm going to draw my graph in black. Steep, 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 flat, 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 steep, 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 flat, 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 steep, steep, steep. Notice it keeps on going forever. But this is one full cycle of the graph y equals sine x. Memorize this shape. Only use 2 vertical lines and 4 horizontal lines to make it simpler for you. So down below, let's graph cos x. Y equals cos x. And again, we're going to make a table of values and say x and y. And say 0, 90, 180, 270, 360. And off to the right, we're going to write the definition of cos. Cos theta equals the x value. Put a red box around it. Now we're going to look at the same unit circle that we were just, the same unit circle that we were before. We know cos theta is the x value. So now we have the angles on the left, theta, and we're going to substitute them in. So we're going to start off with an angle of 0 out to the right, and we're going to take the x value because cos theta is the x value. And the x value to the right is 1. And straight up at 90, the x value is 0. And at 180, the x value is negative 1. And at 270, the x value is 0. And at 360, The x value comes back to 1 again. So again, let's graph it. 2 vertical lines, 4 horizontals, mark 0 degrees, mark 360, mark 180 in the middle if you want to, or just put a tick there. And do the point in this order. Big blue, first point 0, 1. End point 361. Halfway between at the bottom, halfway between on the center line, halfway between on the center line. This is not a V. Flat, 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 steep, 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 flat, 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 steep, 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 flat, flat, flat. Or sketch it in a million little baby strokes. This is cosine. Circle squared in big red, the graph of cosine. Big red off to the left, y equals cosine x. Graphing both sine and x from a table of values from the unit circle. How do you think we're going to graph tan? Well, we could use a table of values. Y equals tan x. That does not look like tan x. Whoops, that's an eraser. Equals tan x. And we can do a table of values the same way. And I'm just going to do it real quick. So do a table of values, make a table of values. Do the same method that we just did using the unit circle, filling out the table. Then we also have to use a few others. You can read a couple of nerd methods about tan is 0 when sine is 0 if you're using that funny formula tan theta equals sine theta over cos theta. But I'm just going to graph it. So we have the y axis, the x axis. I'm just going to mark 180 and 360, always using 2 squares for 180 and etc. And I'm just going to draw it. Close to the vertical asymptote, through the points, close to the vertical asymptote. Replicate this shape exactly off to the right a couple of times. So there's tan x. Now, you're not going to see as many tan x graphing or maybe in the homework, but there's the real life problems for tan are much more difficult. Sine and cos are graphing sinusoidal functions going around in the circle on a Ferris wheel or the moon or a spring. Tangent's a little bit more difficult to comprehend. We're going to see a little bit more tangent graph in grade 12, but those are the sine, cos, and tangent graphs. You may or may not see those, and we're definitely going to be graphing these in grade 12 in degrees and then a new unit. Okay, so that's graphing with a table of values.